the different formulas that we have. Pyramids, cones. Just will you throw me a marker from one of the Expo markers? They're in the box on the, please. And if you hit anybody in the head, that's an extra point.
I'm not going to throw it.
Oh, just throw it!
All right, only because I'm a thrower.
Oh. I see what you did there.
Okay.
Thank you. All right, so. Prism. So we have the two formulas, guys. We have four formulas for surface areas. Pyramids, cones, prisms, was twice the area of the base plus the perimeter of the base times how far apart they were. And then the surface area of the cylinder. Cylinders always have what for the bases? Circles. So we would always say it was 2 pi r squared. The perimeter of every circle is its circumference. Formula for circumference is 2 pi r. So we would write it as 2 pi r, and then how far apart the circles are. So what happens here is that we can take combinations of shapes and put them together. Okay? By taking combinations of shapes and putting them together, we're able to find the surface area. You know, think of it as, have you ever tried to wrap presents before where you just put two of them together just to kind of cover them both up? That's kind of what we're looking at. Okay? We're taking a cylinder and putting a cone on top. That's it. Now, when you start to think about it, I want you to start to think about when you have a cylinder, there's a top and a bottom, or left and right, how are we going to put it? There's two bases, correct? There's two bases, and then you've got the wraparound. In a cone, there's one base, and it's wraparound. Now, since I'm talking about surface area, the moment that I put this on top of here, how many bases can you actually wrap with the wrapping paper? Just one of them. Now, what I want you to think about then is, what would you have to subtract out? Now, here's what I mean. In this case here, we would have, I have the surface area of a cone plus the surface area of a cylinder. Now, that's fine and dandy if they were standing next to each other. The minute they get placed on top of one another, something gets overcounted, shall we say. Two bases, right?
Yeah.
Now, in this case, there'd be two bases that get overcounted. Now, the bases that get overcounted when I'm dealing with cylinders and cones are what? Circles. So for this example, I'd have, find the surface area of my cone, which is pi r squared plus pi r L for the slant height. Surface area of the cylinder, 2 pi r squared plus, bless you, 2 pi r h, how far apart they are. But then I'd have to subtract out two circles because they got double counted. Does that make sense?
Yeah.
You're looking for what we call overlap. What's the whole thing if I took them apart? The minute I put them together, what's the overlap? What's being double counted? Which means I'd have to back out two circles. And I know where you're going with that. Exactly. What I'm trying to show here is by starting with it in terms of the two basic formulas themselves, by saying, hey, here's a cylinder, 2 pi r squared plus pi r h. Here's a cone, pi r squared, pi r l. Put them together, back out 2 pi r squared because there's two circles being overcounted. By doing it this way, before putting any numbers or any values to anything at all, I write it out because just like you were saying, 2 pi r squared minus 2 pi r squared, that cancels it out, doesn't it? That portion becomes 0. So I'm automatically just working with it in terms of the formula before I do the math, before I put numbers in it. Okay? I'm simplifying it prior to. I'm trying to make my work a little bit easier. Does that make a little bit of sense? Okay? So if I do that, I wind up with the pi r squared. Morning, sunshine. How are you, Tuna? Who are you looking for, sir?
Somebody.
Somebody? Need somebody to hug?
Yeah, right. Thank you.
Mr. Peterson, did you want to hug him too? Oh. They say now.
Yeah, right now.
Now.
See you. See you.
See you.
All right.
This
Just
class
takes
is
coffee with them.
half asleep.
That's why I'm loud and obnoxious.
Wake up, kids. Wake up. Wake up.
Okay. So now you have all the information to do the problem. Okay. Yes, sir.
So to find the slant, would you do an a squared plus b squared equals c squared?
That's exactly what you do. It's exactly what you do. And again, it's not that the math part is tough, because just like you've seen earlier, Logan, that most of these problems, it's not just straight, oh, I've got all the information, press buttons on a calculator, be happy, and go on your merry way. I would too. That'd be too easy.
Would you say you'd be shiny?
Oh wait, there's more. She's not here. Come back in about. Sir. The height is for the where you're talking about for that height part. Excuse me. The height portion is the cylinder itself. Yeah, because you're looking at. I didn't cross off the cylinder. Right. Because if I substituted in the other two portions, it wouldn't matter anyway. So the height part is still the difference, the distance between the two bases of the cylinder. Okay. Yes, sir.
Wait, so are you talking about the height of the entire?
No, remember, it's not, I don't want to call it height. I'm calling it the distance between the bases of the cylinder. That's what the H stands for, how far apart they are. Okay. Because cylinders might not be vertical, they can be sideways, they can be diagonal. It's just how far apart the bases are. It's not height. I don't want you to think this is height. Okay. So then you just start putting it together. So we have radius of 5, so we have 5 squared pi plus 5. Now, if this is 5, that's 4, so that's 25 and 16 is 41, I believe.
Yeah.
So the slant height would be the square root of 41, whatever that works out to be. So this would be 5 it should be 5 pi root 41. That's how you would write that out. You put pi in front of the radical. And then after that, we fill in 2, 5, 12, and a pi. Always try to fill out what you're doing before you do it, okay? Because now I see what you have written out. I can backtrack to see how you did it. Because that's a great drawing. Nice work. Not to say yours isn't bad either, but I should have you draw your. So if I do this right, I have 25 pi plus 5 pi root 41. Make sure you hit your right arrow when you're getting out from underneath the radical. That's usually a mistake you guys make. Plus 5 times 2 times 12 pi. I'm getting a decimal of 556.11. 556.11 centimeters squared. Okay. Okay. Again, it's not, yes ma'am. Like Logan was saying a second ago, what you have to do for up here to get, you have to figure out what the slant height is. You've got the vertical height of the cone, and you've got the radius. So you've got the vertical height, the radius, find the slant height. That's 4 squared plus 5 squared is your L squared, your slant height. Please use that. That's usually what you're going to wind up doing a lot of times with these. Okay? No problem. So it looks like it's going to be awful, but in essence, you're just piecemealing together things that you have done. Okay? And guess what? It works the exact same way. Oh, that's gonna be a bad picture. It works the same way when you have pyramids and prisms. Okay? It's the exact same thing, but you're just doing different formulas. What's that? Exactly. All right. Now remember, excuse me. The formulas that we've been using, for the what do you call it? The pyramids. Those have all been regular polygon-based pyramids. So in this case here, since that pyramid is on top of a rectangle prism, that means it has to be a square base. Is everybody okay with that? What's up? Wait, you know it's mine versus my wife's. So what we have then is going to be a prism plus the surface area of a pyramid. Well, what would you have to subtract out then? What do they share? Two bases. And these bases are two squares. So I'd have to subtract then two, I'm just going to put B for right now. I'm just starting it like that. Okay? Formulas. Prism, twice the area of the base, perimeter base, and how far apart they are. You need to remember that, excuse me, in this case, since the pyramid, these pyramids are always going to be regular polygon based, that means that this has to be a square prism. A square prism is called a what? A cube, very good, it's a cube. All right, the square prism is called a cube. So we write it out, we have twice the area of the base, perimeter of the base, times how far apart they are, plus another base, plus 1/2 the perimeter, times its slant height, and then I have to subtract out two of the bases. Now remember, our bases here are all squares. So I know that that first 2b, which is no longer, it's not 2b, no, sorry. Yeah, exactly. So before I start filling in all my blanks, before I start filling all my blanks, I know that these two simplify themselves out. Because I'll have two squares at the front end, I have to subtract out two squares at the back end. It gives me 0. Yes, ma'am. When we have, and I apologize, I don't have a square pyramid in a, do I have a square pyramid? I do. I forgot that I did. Do I have a pyramid?
It's on your desk.
Oh yeah, there is. I didn't see it. Oh, thank you. It blended in. Pyramid. Prism. Two bases. If you wrap this up, you have to cover all 5 sides. If you wrap this up, you have to cover up 6 sides. Put this on top of here, but 2 sides don't have to be wrapped. That's where it comes from. Does that make sense? So you start filling it in then. We know that the perimeter, what's the perimeter if all sides are 5? How far apart are the bases of the prism? 5. What's the area of the base of a square that has side lengths of 5? 25. Remember, side squared, length times width, base times height. Any one of those means the exact same thing. You still have one base you have to account for, so it's going to be a 5 by 5. Plus half the perimeter again, which was 20. And now, excuse me, now we have the vertical height of the pyramid at 3. Remember where the vertical height of the pyramid goes to. The vertical height of the pyramid goes to what spot? The very center of the square. Okay. Now, if you look at the back wall there, I have a diagram of a square where we have the center to the side. Remember, the center to the side of the pyramid would be called its apothem. But since we have a square, and this is dead center, exactly. If the side lengths are 5, that means this has to be 2.5. Now, I went from a flat surface of this being 2.5 to raising it upward to creating the triangle then. Okay? So now I've got a vertical height of, what is it, 3? And I have a leg of 2.5. So what I've created then is the right triangle with side lengths of 3 and 2.5. And I use Pythagorean theorem to use to find my slant height. Okay? I am switching, it's basically you're switching from a two-dimensional surface, the flat surface, and rearranging it so that it becomes a vertical surface so you can see what's going on. All right? That's what this stuff does. It's not that the math is difficult, but each of these problems are very similar in such a way that you have to go to, how do I make this work from an apple? What does that mean when I'm looking at the center of my square-based prism? Why does that work? Well, because that is the dead center spot from the vertical height. Half of 5 is 2.5, and so on. Okay. Does it help with these little visual thingies?
Yeah.
These things are great. Even if I only have to use them once a year, these are well worth it.
What do they cost? $20?
$7 million. Okay. So now, in this case, when you guys Pythagorean theorem did, what'd you get for your slant height? 3.9? Okay. So then I put all of that together, and I'm going to get my, excuse me, I will then get my surface area. So we have 100, 125, 125, and 39 would be 144.
164.
Oh, yeah, I was going 39, I was adding 20. All right. So 164 square inches, inches squared, square inches out of them. Okay. And that stems from remembering that vertical heights drop right to the center. That vertical height goes to the center of this. If it didn't, it wouldn't work. That picture, hold on. Okay. There are two cones. You have surface area of the cone on the top and the surface area of the cone on the bottom. All right? As you look at that, your two cones have formulas. Pi r squared plus pi r L. That's the top one. Shh, guys. The bottom one would be pi r squared plus pi r L. Those two cones have circles for bases. In that diagram, could I wrap either of those circles with wrapping paper? Nope. So I have to subtract them out. So I have to subtract out two circles. Those two circles are the exact same as the bases for the top cone and the bottom cone. Correct. But I want you to, just so you remember what's being backed out. It's an easy way to not make a mistake. So now you have your final formula of pi r L for the top plus pi r L on the bottom. Well, you've got a 3 and a 4, which gives you a slant height of 5 for the top one, okay? A 3 and an 8, which gives us a slant height of, well, 3 squared and 6 squared, is that square root of 73?
Yeah.
I said, yeah, 9 to 64 is 73. Yes. Did I? Well, I thought it said 3 squared plus 8 squared. That's what I meant to say. Can't you understand what I'm thinking right yet? I mean, it's almost June. So we wind up with 3 by 5 pi plus 3 root 73 pi. Put that all together in the calculator, you get some crazy decimal. What is those? I can't hear you when you're.
126? 27.
What are the decimals? 126.65. If you did the pi here, you probably won't be able to because you got the root 73. You'd have 15 pi plus 3 root 73 pi. That would be the exact answer because you can't combine them because of the radical.
I got 35.
We did the same slide. We didn't change it. Okay. We did the same slide.
What'd you say?
We did the same slide.
Oh, I understand that. You gotta talk about that. You did it weird. Yeah, the calculator added it.
All right.
Yeah, it was cool.
You get 127. 127. Oh, they got 127. Sorry, I heard 16. That's all. Yeah, this is. It is 127, guys. I apologize. I heard someone say 6, and I wrote that down quickly. Okay. All right. Oh, nuts.
So for the second
On this sheet, let's do number 6, 9, 10, and 14. Yes. Yes, please.
Oh, 14.
14 is actually really easy. They give you everything. 14 gives you everything. Your apple there, everything's there. You just have to apply to figure out what is being backed through. Okay?